There are more than 400,000 known species of beetle. That is more than every mammal, bird, reptile, amphibian, and fish species combined. But the number is not the strange part. The strange part is what those beetles became. One reads the Milky Way, one farms fungus and alcohol, one steals poison from its victims, one carries a chemical cannon in its abdomen, and one can be run over by a car and keep walking. So to understand beetles, you do not start with wings or shells. You start with survival. For more than 300 million years, evolution has kept asking beetles the same question. How do you stay alive in a world full of mouths? Every beetle answers differently. A small beetle climbs onto a ball of dung beneath the night's sky. It turns in a careful circle. Then it rolls that ball away in a straight line, guided by the glow of the galaxy. This is the dung beetle. It may fit under your thumb, but some males can pull 1,141 times their own body weight. For a 154-pound person, that means dragging 6 loaded double-decker buses. The dung ball means food, it means shelter, it means offspring. But the pile it came from attracts thieves, so the beetle must escape fast and straight. Researchers placed tiny caps over dung beetles' eyes. With the sky blocked, they lost their way. Under a planetarium, with only the Milky Way projected above them, they found their line again. Not the sun, not the moon, the galaxy. It does all this for a ball of waste. That beetle solves survival by reading the sky. Another solves it by turning its face into a tool. A female beetle stands on an acorn and begins drilling with a snout longer than her body. If that snout bends, she fails. If it snaps, her offspring die. This is the acorn weevil. Its long snout, called a rostrum, works like a living drill bit. Inside it, fibers of chitin spiral through the structure, spreading force the way steel cables strengthen a bridge. Not because the snout is thick, not because it is straight, because it bends without breaking. She drills deep into the acorn, turns around, and lays an egg inside. The larva hatches sealed in darkness, surrounded by food. To you, it looks like a seed. To the weevil, it is a locked nursery. The adult looks delicate, the engineering does not. But drilling rewards patience. Some beetles survive because they remove patience from the equation. A beetle lies on its back with no room to run and no time to turn over. It bends its body, locks a spring in its chest, and launches itself into the air with 400 Gs of acceleration. This is the click beetle. It does not jump with its legs. It snaps a hinge between the front and middle parts of its body. A rubbery protein stores tension. A tiny latch releases. The whole beetle fires upward. If your body took 400 Gs, your organs would not stay where evolution placed them. The click beetle lands badly, often more than once. That does not matter. The point is escape. A spring can save you from danger on the ground. Speed creates a different danger. Imagine sprinting so fast that the world disappears. A predator races across bare sand at 120 body lengths per second, fast enough that its eyes cannot gather light quickly enough to form a clear image. It goes blind during the chase. This is the tiger beetle. For a human, that would mean running about 480 miles per hour and crossing a football field in less than half a second while the world smears into color and noise. So the tiger beetle hunts in bursts. Sprint. Stop. See. Sprint again. Its antennae point forward in a stiff V, hovering just above the ground. When they hit a pebble or twig, the beetle vaults before its eyes catch up. It hunts by outrunning its own nervous system. Nothing about that sounds sensible. It works anyway. And if speed breaks vision on land, water demands a stranger compromise. A beetle skates across a pond with its body split between two worlds. Half its eyes watch the sky. Half its eyes watch beneath the surface. It sees the bird above and the fish below at the same time. This is the whirligig beetle. Its compound eyes divide into upper and lower halves. Its middle and hind legs flatten into oars. During the power stroke, they spread wide. During the return stroke, they fold to reduce drag. That rowing system turns about 84% of its energy into thrust. Touch the water nearby, and the beetle feels the ripples. A struggling insect writes its position into the surface, and the whirligig reads the message. The pond looks calm from above. For this beetle, it is a vibrating map. Water gives one beetle 2 worlds to watch. Fire gives another a world to chase. Some beetles fly towards smoke, not away from it. A burned forest means dead trees. Dead trees mean a nursery with fewer living defenses. So this beetle searches for disaster across distances that strain belief. This is the fire chaser jewel beetle. Its body carries heat sensors that detect infrared radiation, the invisible warmth given off by flames and hot wood. Large fires may call to it from 60 to 100 kilometers away. That is like standing in New York and sensing a bonfire near Philadelphia with patches of living skin. The adult arrives while ash still holds heat. It lays eggs in freshly killed trees. Its larvae grow where the living forest has just ended. For most animals, fire means flight. For this beetle, fire means a future. But not every beetle waits for nature to prepare the nursery. Some build farms in the dark. A beetle smaller than a grain of rice bores into a weak tree carrying fungus in pockets on its body. It plants that fungus in tunnels. Then it uses alcohol in the wood to poison the weeds. This is the Ambrosia beetle. It cannot live on wood alone. Its larvae eat the fungus it cultivates. The beetle chooses stressed trees because those trees contain ethanol, the same alcohol found in drinks. Many competing molds struggle there. The beetle's crop fungus survives and detoxifies the alcohol, not because the beetle understands agriculture, not because it plans a harvest, because natural selection shaped an insect that carries spores, chooses a chemical field, and raises young on a crop it planted. Humans invented farming thousands of years ago. Beetles reached that solution long before us. Farms invite thieves. Fire invites opportunity. Light, the softest signal in the summer dark, can become a trap. A male firefly flashes his code over the grass. He expects an answer from a female of his own kind. The answer comes. He lands. Then the light kills him. This is the predatory Photurus firefly. She copies the flash pattern of another species, often the mating signal of a photinous female. When the male approaches, she seizes him and eats him. The meal gives her more than calories. It gives her lucibufagins, defensive chemicals her own body cannot make. Those chemicals help protect her and her eggs from jumping spiders. She steals armor by eating the animal that made it. The male comes searching for reproduction. He becomes medicine. The glow still looks gentle from across a field. Up close, it is a forged signature. Some beetles steal chemicals. One manufactures a weapon inside its own body. A predator grabs a small beetle from behind. The beetle bends its abdomen, mixes two chemicals in a chamber, heats them past boiling, and fires the blast into the predator's face. This is the Bombardier beetle. Inside its body, two chemical ingredients wait in separate storage chambers. When danger arrives, the beetle sends them into a reaction chamber lined with enzymes, proteins that speed the reaction. The mixture reaches about 105 degrees Celsius. Pressure rises, steam forms. The beetle blasts the boiling spray through a movable nozzle. Then the mechanism gets stranger. A flexible membrane swells under pressure and closes the inlet. The chamber fires. Pressure drops. The membrane relaxes. More chemicals enter. The cycle repeats in rapid pulses. It is not one spray. It is a controlled series of micro-explosions. Nothing eats the Bombardier beetle twice. Remember the click beetle's spring. Remember the firefly's stolen chemistry. This beetle combines timing, heat, pressure, and aim in a body smaller than your fingernail. But a weapon only helps if you survive the first bite. Another beetle chooses not to run, jump, spray, farm, flash, or hide. It becomes difficult to break. A desert beetle can survive a crushing force of 149 newtons, about 39,000 times its own body weight. Researchers have compared that to a person surviving dozens of battle tanks stacked on their chest. This is the diabolical Ironclad beetle. Its hard wing covers no longer open for flight. They fuse into armor. Along the center line, the two sides lock together like puzzle pieces. Under pressure, they do not snap. They peel apart, inside, layer by layer, spreading force through the shell. Not because the armor refuses to fail, because it fails slowly, locally, and under control. A car tire can roll over it. The beetle walks away. That should feel like the limit. Armor that defeats crushing, chemistry that boils, eyes split by the waterline, a runner so fast it outruns vision. Then a beetle appears that breaks the pattern in a quieter way. It spends years underground building a huge adult body with heavy armor, broad wings, and jaws strong enough to snap a pencil. Then it emerges unable to eat. This is the Titan beetle. The adult lives on stored energy from its larval life. It must fly, find a mate, reproduce, and die before its reserves run out. Its enormous jaws can defend it. They cannot feed it. Peak form becomes the deadline. Every beetle so far has gained some tool for survival. This one shows the price. Evolution does not make champions. It makes bargains, and the strangest bargain begins with a creature almost powerless on its own. A newborn larva hatches in desert sand. It cannot fly. It cannot hunt. It cannot drill into wood. It cannot overpower the animal it needs. So hundreds of larvae climb a plant stem together and become one lie. These are blister beetle larvae. Freshly hatched, they look like tiny orange specks. They gather at the top of a plant and hook their bodies together until the mass resembles a female solitary bee. Shape is not enough. They also release chemicals that mimic her scent. A male bee finds the signal. He tries to mate with the mass. The instant he touches it, the illusion breaks. Larvae clamp onto his hairs. He flies away carrying them. Later, when he mates with the real for female, the larvae transfer onto her body. She returns to her underground nest and seals them inside with pollen, nectar, and her own egg. The beetle larva eats the egg first. Then it eats the food meant for the bee's child. Not strength, not armor, not speed, not heat. A scent, a shape, a mistake. A mistake so precise that an entire childhood depends on another animal falling for it at the exact right moment. There are 400,000 known species of beetle, 400,000 bodies, 400,000 strategies, 400,000 answers to the same question. How do you survive on a planet that keeps inventing new ways to kill you? One grows a drill, one reads the Milky Way, one goes blind from speed, one farms fungus and alcohol, one steals chemical armor from a lover, one fires boiling liquid from its body, one turns its back into a living crash structure, one begins life as a swarm pretending to be a bee. The shell was only the beginning. What beetles reveal is not perfection. Nature rarely builds that, it builds trade-offs, shortcuts, narrow escapes, terrible bargains that work just long enough for offspring to exist, and in beetles, those bargains have multiplied until they cover the planet. You have seen what these beetles can do from the outside. The harder question is what it feels like to live as one. To sprint blind, breathe underwater, smell fire from beyond the horizon, or wake inside an acorn with the whole world sealed around you. That is where the next story begins.